Hi everyone. The topic for this video is inventory model without shortage. Let me first explain what inventory model is. Inventory model is a mathematical model that helps business in determining the optimum level of inventories that should be maintained in a production process, managing frequency of ordering, deciding on quantity of goods or raw materials to be stored, tracking flow of supply of raw materials and goods to provide uninterrupted service to customers without any delay in delivery. There are two types of inventory model widely used in business. Number one is inventory model without shortages and inventory model with shortages. As I've told you, the topic for this video, inventory model without shortages. In this model, we have to calculate the EOPQ value for the calculations. Starting with EOQ is the acronym for economic order quantity. The economic order quantity is the optimum quantity of goods to be purchased at one time in order to minimize the annual total cost of ordering and carrying or holding items in inventory. EOQ is also referred to as the optimum lot size. We begin with the EOQ calculations without shortage. In this model, the following assumptions are made. Number one, demand is at constant rate D. All cost coefficients C1, C2, C3 are constants. There is no shortage cost or C4 is equal to 0. The replacement rate is finite and greater than the demand rate. This is also called replenishment rate or manufacturing rate denoted by R. Schematically, this model is illustrated in figure 4. As you can see, this is slope equal to R minus D, slope equal to D, time on the x-axis, Q on the y-axis. Going with the next slide. The total cost of inventory per period is a sum of three components: item cost, order cost, and items holding cost. Let IM be the maximum inventory, TL be the time of manufacture, and T2 be the time during the which there is no supply. In this model, all items required for a cycle are not stored at the beginning as in Wilson's model. The items are manufactured at a higher rate than the demand so that the difference R minus D in the existing inventory till the items are exhausted. Here we can see item cost per period is C1 into Q. Order cost per period is equal to C2. Item holding cost per period is equal to C3 into IM into T1 plus T2 divided by 2, which is C3 IM into T by 2, and IM equal to T1 R minus D. But we can see that T1 can also be written as Q by R, and therefore IM equal to Q by R into R minus D. Substituting the values of IM, we get the inventory cost of inventory per period, where C dash equal to C1Q plus C2 plus C3 Q by R into R minus D into T by 2. Next, we can see the total cost of inventory per unit time is C equal to C dash by T. But T is equal to Q by D. Therefore, substituting the values of T, we get C equal to C1D plus C2D by Q plus C3Q by R into R minus D by 2. Now, we differentiate C with respect to Q, and setting equal to 0 for minimum C, we get dC by dQ equal to 0 minus C2D by Q square plus C3 R minus D by 2R equal to 0. Solving the previous equation, we get Q star equal to root over 2C2D by C3 into root over R divided by R minus D. This will give the economic order quantity and is a balance between holding and setup costs. So now let's take an example to discuss about the topic. An auto parts supplier sells Hardy brand batteries to car dealers and auto mechanics. The annual demand is given as 1200 batteries. The supplier pays rupees 28 for each battery and estimates that the annual holding cost is 30% of the battery value. It costs approximately 20 rupees to place an order, and the supplier currently orders 100 batteries per month. So as you can see, we have to calculate the ordering, holding, total inventory cost, the EOQ, how many orders we place per year using the EOQ, and also determine the ordering, holding, and total inventory cost for the EOQ. Let's start with the annual demand is given as D equal to 1200 batteries per year. The cost C is 28 rupees per battery. Holding cost is rupees 0.30 into 28 equal to 8.402 rupees per battery per year. And order cost is 0 per order, and current order quantity is Q equal to 100 batteries. To calculate the current ordering, we have current ordering equal to D by Q into order cost, and we get as 240. The holding cost is given by Q by 2 into holding cost equal to 100 by 2 into 8.40 equal to 420. So to calculate total inventory cost, we add them both and we get it as rupees 660. To calculate the EOQ, we have from the formula given here, we substitute the values and then we get Q equal to 76 batteries. Now to calculate how many orders the company will place, we'll calculate D by Q star equal to 1200 by 76 equal to 15.3 orders per year. And finally, to determine the ordering, holding, and total inventory costs for the EOQ, we use D by Q star into ordering costs plus Q star by 2 into holding costs. So simplifying everything, we get rupees 634.99. Therefore, the company sales are rupees 25.01 kg using EOQ. That's we have for the video. I hope you liked it. Thank you.